Mr. Cunningham for Common Maths. Today we're going to do National 5 Maths and we're going to look at the whole of arcs and sectors in National 5 Maths. Let's get into it. So these examples are taken from the excellent website maths.scot, so make sure you use that for your revision and look out for the National 5 Maths app at the end of the month on Clelland Maths. A sector has a radius of 5 centimetres. The angle at its centre is 41 degrees. Calculate the arc length in the area of the sector. So sectors are just fractions of a circle, and a whole circle's got 360 degrees. So all you need to know is your fraction is your angle out of 360. So for part A, to get your arc length, is 41 out of 360 times, well, pi times diameter for circumference. So pi times diameter is 10 because double the radius. And then we get a calculator to work that out. 41 divided by 360 times pi times 10 gives me 3.577. Which I'll probably round to 3.6, but I always like we run a rounded answer first. And I think that was centimetres. Yep. Part B. Sector area. Well, angle over 360 times pi r squared for an area of a circle. Pi times 5 squared. So again, that's just a calculator job. 41 out of 360 times pi times 5 squared is 8.944. 8.944, or to one decimal place, so that's 8.9 centimetres squared. And we're done there. This video is sponsored by Lecky, and they are offering viewers of this channel 30% off of any of their books. All you have to do is use the code Clelland Maths, and the link to their books is down below. Now let's look at a couple of their books to highlight. We've got National 5 Maths and Higher Maths, and these are complete revision and practice. 2 books in one. We cover the whole course. Here's a random page, for instance, working simultaneous equations algebraically. You can see how good that book is and how clear it looks. But also at the end, practice exam papers that look exactly like the SQA exam papers that are published. Discount code Clelland Maths. Click the link to order now. Example 2. A sector has a radius of 3 centimetres and an angle at its centre of 120. Find the arc length in sector area. Use 3.14 instead of pi. So in other words, this is non-calculator. We need to be able to do some maths without a calculator. So for part A, still works exactly the same. Arc length is angle over 360 times pi times the diameter, because it's a length. So diameter is not 3, it is 6. Now, when you're doing this, I would simplify all your fractions first. Well, 120 goes into 363 times, so that's 1/3 times pi, which we said was 3.14 times 6. And leave the 3.14 to the end if you can. You can do a third of 6 first. A third of 6 is 2, so it's 2 times 3.14. I think it is doubling that then, that's 8. That's 2, that's 6.28 centimetres. Let's do the same for the area part. 120 over 360 times pi times r squared, 3 squared. That's 120 over 360 becomes a third, times 3.14 times 3 threes is 9. Well, that's just a third of 9 is 3 times 3.14. So I'm leaving that again. 3.14 to the end because it's the hardest to deal with. 3 times 3.14, well, 3 fours is 12. 3 ones is 3, plus 1 is 4. And 3 threes is 9, so 9.42 centimetres squared. And we're done there. Example 3. A sector has a radius of 50, the angle is 72 at the centre. Find the arc length in sector area. Again, it's non-calculator, so I have to use 3.14 for pi. So B, for part A, our arc length is angle over 360 times pi, which is 3.14, times the diameter, 50 times 2, 100. Simplify my fraction first. So 72 to 360, you can take your time simplifying that, and you'll realise, though, that 72 actually goes into 365 times, but you might not realise that, so you can just keep halving until you get down to 1/5. You get 1/5 times 3.14 times 100. Leave your 3.14 to the end if you want. So 1/5 of 100 is 20. So I'm timesing a number by 20 and a decimal, so I'll just times it by 10 first and then 2. I'll show you that there. So that's 2 times 31.4, which is 62.8 centimetres. Part B, area equals angle over 360 times our pi, and this time it's 50 squared, the radius. So that equals 1/5 times 3.14. 50 squared is 50 times 50. 5 5s is 25, so that's 2500. But again, we can divide by the 5 first. 5 into 25 is 5, so that's 500 times 3.14. We can split that up into 5 times 100, so 5 times 100 lots of that is 314. 5 times 314, well, 5 4s is 20, 5 1s is 5, 6, 7, and 5 3s is 15. So we get 1570 centimetres squared, and we're done there. Example 4 in arcs and sectors. A sector has an arc length of 12 and a radius of 7. Find the angle. Remember, angle, I'll just write angle as a theta, that's the general for an angle, over 360 times pi times the diameter equals the arc length. So we're just subbing in everything we know. So we've got angle over 360. We don't know our angle, but we know our pi. We know our diameter, double 17 is 14, and we say that that arc length is 12. So we're working backwards from there. So pi times all of that divided by that equals 12. So we've obviously divided as times. So that means that our theta equals 12 times 360, what we divided by, all over, well, it's just going to be pi times 14. So we just got a calculator to work that out. 12 times 360 divided by brackets, pi times 14 is 98.2 degrees, or 98 degrees. And we're done there. Example 5. A sector has an area of 115 millimeters squared and a radius of 8. Calculate the angle. So angle, let's call it A for this answer, over 360 times pi times the radius squared, 8 squared, equals 115. So we need to work backwards from A to get A. So again, we've divided on this side by 360, so if we times by it, that'll get rid of the fraction. But then we need to divide by everything that was being times by, so divide by this. So we're dividing by, we're timesing by with 360 and dividing by the area of the circle. So A equals 115 times 360 then, divided by pi r squared. I'll just use a calculator to work that out. 115 times 360 divided by brackets pi times 8 squared equals 205.906. Or about 205.9 degrees. And we're done there. Example 6. A sector has an arc length of 7.79. The angle is 72. Calculate the radius. Angle over 360 times pi times diameter equals the arc length. So I can write all of that down and then work backwards. So if we want to leave the 72 where it is, we need to times by 360 to start with, because we're divided by it. So then we want to find the diameter, because pi is just a number. 7.79, I prefer little lines with my sevens, as you've probably noticed, times 360. So we divide by 72 times pi. And that's going to give me my diameter. So I'll just grab a calculator. $12.398. So that means our radius is half of that. So we can just divide that by 2 in our calculator. 6.199 or about 6.2 centimetres, and we're done there. Example 7. A sector has an area of 17.3 centimetres squared. The angle is 153 degrees at the centre. Calculate the radius. Angle over 360 times pi times r squared equals the area of 17.3, which is told to us. So we'll just work backwards from there. That means that pi r squared, well, 153 lots there, if we want to take it slow, is 17.3 times 360, because we're originally divided by 360. So I'll need to get r squared on its own. So that's 17.3 times 360 divided by whatever's next to it now, which is 153 pi. So then to get r, we're going to have to square root that. So you can do that all in one go using brackets, or just take your time. I'll just take my time. 17.3 times 360 divided by brackets pi times 153 is 12.95708. A bunch of other numbers, but that'll be enough. So my radius equals the square root of 12.95708, because I've got r squared, remember, opposite square and a square root. 3.599, or about 3.6 centimetres. So notice in terms of rounding here, this is a good one to notice. I have not rounded that much, because you don't want to round that to 13, then square root it, and then round it again. You're double rounding. So I'm keeping that nice and long, then writing down a long answer again, and then rounding somewhere appropriate, and that will keep you right. Example 8. A sector has a radius of 5 centimetres and an arc length of 6.28. Find the angle at the centre. Use pi equals 3.14. I think it's a grade A question that was to come up, so let's have a look at this one. We'll have to find the angle over 360. It tells us the arc length, so times pi times the diameter, double 5 is 10, equals our arc length of 6.28. So subbing in pi as 3.14, we've got that. So now we need to make A the subject. So to get A the subject, we'll say we've got 6.28 divided by 360 means we're timesing by it. And then we're dividing by all the rest, because that's next to the A, 3.14 times 10. Now that looks really tricky, but that and that can be cancelled, and that can be cancelled to leave an easier sum, because it's just a times in between, so you can do that. 3.14 times 2 is 6.28, so that gives you 2 times 360 divided by 10 is 36. So then suddenly you've got an answer, 72 degrees, and we're done there. So on arc length, we've got SQA National 5 Maths 2015 Paper 2 Question 10. Had this question: the pendulum of a clock swings along an arc of a circle with centre O. So you've got 65 degrees here. The pendulum swings through 65 degrees. The length of the arc is 28.4. Calculate the length of the pendulum. So we're working backwards from arc length, but it mentions length of arc, so we can substitute in. So the writing down arc length, again, equals angle over 360 times pi times diameter. When we substitute everything in we've got, so it's told us the arc length is 28.4, so I can write 28.4 equals our angle, which is 65, over 360 times pi, but I don't know the diameter, so I can just write times diameter. Now I find the easiest way to work back here is you could either try and rearrange it directly, or what I like to think of is, usually I do divide by 360 and times by everything else. So for going backwards, I'll do the opposite, which means I'll times by 360 and divide by everything else. So I can immediately write down that D equals, starting with 28.4 for the left-hand side, I'm going to divide that by, well, everything on the top that's normally times. So 65 times pi is going to go on the bottom. Then the thing that's usually divided is 360, so I'm going to times the top by 360. And I get my D straight away that way. And then I just go to a calculator and work that out. So I just do 28.4 times 360, and then divide by 65 times pi. I can use brackets around the top and brackets around the bottom, and if you do that, you will get an answer for D, which is 50.07 centimetres. Now, we'd usually be finished here for calculating the diameter, but it asks us to find the length of the arc, the length of the pendulum. Well, if that was to go all the way around, it would be a circle, and that would be a radius. So the length of the pendulum is half that. So our length is equal to 50.07 divided by 2, which to a reasonable degree of accuracy is 25 centimetres. SQA National 5 Maths 2016 Paper 1 Question 3 for area of a sector. The diagram shows a sector of a circle, centre C, and the radius is 20, the angle is 45. Calculate the area of a sector without a calculator. So we'll start off with the same way. Area equals angle out of 360 times pi r squared, and we calculate that by putting 45 out of 360 times pi times 20 squared. 2 marks so far, 1 mark for getting the fraction and 1 mark for substituting in, and now we just need to do lots of work to get the actual answer for our final mark. So fractions we simplify, so 45 into 360, well 45 goes into 360 8 times, so I get 1/8 times pi, 20 times 20 is 400, so I do an 8 for 400 is 50 times pi, and then again you can just at the side do 3.14 times 5, 5 4s is 20, 5 1s is 5 plus 2 is 7, 5 3s is 15, you get 15.70, so that gives you, that's times by 5, so it's 10 times 15.70, which is 157 centimetres squared for our final answer. Another quick way at this point would be to times by 100 and then divide by 2. SQA National 5 Maths 2017 Paper 2 Question 14 on arc length. The diagram shows part of a circle, centre O. It says the radius is 6.4, the length of the major arc is 31.5. Calculate the size of the reflex angle AOB, in other words this angle here. So we're just using arc length again and working backwards. So we'll just write down everything we've got. So arc length, I'll just write AL equals angle over 360 times pi times diameter. We've got the arc length, that's 31.5 on the left. We've not got the angle, so I'll just write theta or x or anything you want, over 360 times pi times, now be careful, the diameter is not 6.4, that's the radius, so I double that to get the diameter of 12.8. Now if you can get that far, you get a mark. Angle over 360 times pi times 12.8, and then we need to work backwards. So again, remember, we start with this, so our angle equals 31.5, and I'm going to divide by everything on the top, pi times 12.8, and we're going to times by everything on the bottom, 360. Then we get a mark if we can get that far, and then for a mark for our final answer for calculating our angle theta, when we do 31.5 times 360 divided by brackets pi times 12.8 is 282.003, or to a reasonable degree of accuracy 282 degrees for our final answer. SQA National 5 Maths 2018 Paper 2 Question 2 on arc length. The diagram below shows the sector of a circle, centre C. It shows the radius is 7.4, the angle is 320, and it asks us to calculate the length of the arc. So this is a straightforward one. We can just write down arc length equals angle over 360 times pi times diameter. Always write down your formula first. Your angle is 320. We've got that over 360. And we're timesing by pi. And our diameter, well, it's told us 7.4. So we need to double that, so that is 14.8. Get a mark for writing down our formula. We get a mark for getting our angle, 320 over 360, our fraction, 320 over 360. And then a mark for our final answer, which worked out at 41.32 centimetres. And we're done there. Next grade National 5 Maths 2018, Paper 2, Question 2 on arc length. The diagram below shows the sector of a circle, centre C. It shows the radius is 7.4, the angle is 320, and it asks us to calculate the length of the arc. So this is a straightforward one. We can just write down arc length equals angle over 360 times pi times diameter. Always write down your formula first. Your angle is 320. We've got that over 360. And we're timesing by pi, and our diameter, well, it's told us 7.4, so we need to double that, so that is 14.8. Get a mark for writing down our formula. We get a mark for getting our angle, 320 over 360, our fraction, 320 over 360. We get a mark for our final answer, which worked out at 41.32 centimetres. And we're done there. Next grade National 5 Maths 2019, Paper 1, Question 4 had this arc length question. It says the radius is 30, the angle is 240, calculate the length of the major arc. Now this is Paper 1, so it's non-calculator, so I'm going to give you some hints for this one. You still start off in the same way, don't be worried. Arc length equals angle out of 360 times pi times diameter. Now we can just substitute in. Our angle is 240 out of 360 times by pi times by 60. Double 30 makes 60. So now at this point, you might be wondering, what can I do? Well, to calculate this with a non-calculator, always best to simplify any fractions first. So I'm just going to take it beside 240 over 360. I can drop the zeros to straight away to get 24 over 36. And then I'm looking for two numbers at times together to make 24. Two numbers, a number that goes into 24 and 36. Well, 4 goes in, I know that straight away, so I'll divide by 4. 4 sixes is 24, 4 nines is 36. Oh, I can see 3 goes in as well. And you could have got there quicker by dividing by 12. 3 twos is 6, and 3 threes is 9. So our sum now can be replaced with this fraction. I've got arc length is 2/3 times pi times 60. I'll leave the pi to the end. So I've now got 2/3 of 60. So I divide by 3 and times by 2. 3 20s is 60. 20 times 2 is 40. So I've got 40 times pi. So that's 40 times 3.14. So we need to do this sum. So there's lots of ways to do it, but times them by 40 is the same as times them by 10 and times them by 4. So again, at the side, you can just do 3.14 times 4. 4 fours is 16, carry 1. 4 ones is 4, plus 1 is 5. 4 threes is 12. So you get 12.56. So that is 10 times 12.56, which is 125.6. And our units were centimetres. Grade National 5 Maths 2023, Paper 2, Question 3. The diagram shows part of a football pitch. The penalty spot is marked at C. AB is an arc of a circle, radius 9.5. Calculate the length of the arc length. So arc length is just angle, 106 degrees out of 360 degrees, times by pi times by diameter. So diameter, well, the radius is 9.15, so the diameter is 9.15 times 2, which is 18.3. So times 18.3. That gives me a total of 16.9279 meters, or you could round it to just 16.9 meters, I suppose. And we're done there. Grade National 5 Maths 2024, Paper 2, Question 15. The diagram shows the sector of a circle, centre C. The radius is 12. The length of the arc is 15. Find the area. Well, that's a bit of a dodgy one. So to find the area of a sector, I need the angle. So I'm going to have to work backwards from the arc length. So let's call that theta, or anything you want. Arc length, angle over 360, times pi, times the diameter, which is double 12, 24, equals the arc length, which is 15. So working backwards from there, I can immediately get theta, so I always do it this way. I've divided by 360, so I times this side by 360. 15 times 360, all divided by pi times 24, because that's on top. (15 times 360 divided by, open brackets, pi times 24 is 71.6 degrees. So there's my angle. So now I can work out the area, because the area is the angle out of 360 times pi times r squared, which is 12. There's other ways to do this, but this will be fine. 71.6 divided by 360 times pi times 12 squared is 89.975. And it's centimetres squared, or you can just round it if you want, but it would round up to about 90.0 centimetres squared, which I never like the look of, so I'd probably prefer just to unround it. Screen National 5 Maths 2025, Paper 2, Question 6. A party is made in the shape of a cone as shown below. The piece of a card is used making the hat as a sector of a circle, centre C. The radius is 15, the angle ACB is 170. Calculate the area of the sector. Angle over 360 times pi times r squared, which is 15. So it's just a calculator again. (333.7942) or 333.80 centimetres squared. And we're done there. So this is Clelland for Clelland Maths today. We did the whole of arcs and sectors in National 5 Maths. Hopefully you found that useful. Take care, stay safe, and goodbye.